champions, and welcome back to the Science Lab. Hopefully you all had a good fall break. This is our first science video from returning from fall break for this Tuesday activity. Before break, we talked about energy and all of its different forms, and we started talking about waves. Waves of water, light waves, and sound waves. You had a few videos where you saw Mr. Chambers play some instruments or explain photography and how that captures the light energy. And now, moving forward, we are going to be talking about invisible energy here in Chapter 4. So, as always, after our science video, there will be 5 to 10 questions for you to answer in Google Classroom based off of the reading. So without further ado, let's begin with Chapter 4, Invisible Energy. Chapter 4, Invisible Energy. Our big question for today are what are some different kinds of light waves? Okay. You know that different colors have different frequencies. We talked about this with photography and the light waves. Color has different frequencies. The higher the frequency, the more waves bounce in between. The cooler the color is, and the slower the frequency, the warmer the color would be. Okay? The color of an object is the reflection of the wavelength for that color. All other colors in the wavelength are absorbed by the object. All the colors and all the wavelengths of light that humans can see are called visible light. This is what we can see. Okay? So all the light that we can see. When you go out When you go outdoors on a sunny day, you need to wear sunscreen to keep your skin from burning. But what kind of invisible energy can burn your skin from a distance? Ultraviolet energy waves have a shorter wavelength than visible violet light. What are the other wavelengths that we don't see? Well, let's keep reading to learn some more. So, ultraviolet light, more than violet, so your deepest purples. There's colors we can't see in that same spectrum with higher frequencies that can burn us from the sun with light energy that takes 8 minutes to reach us over 93 million miles. Infrared and ultraviolet light. Some light has wavelengths that are longer than visible red light. This light is called infrared light. We can't see infrared light, but special cameras can detect it. Infrared cameras allow us to see warmer and cooler objects in pictures. Infrared light is also used in most television remote controls. A beam of infrared light goes from the remote to the TV, and changes occur when the energy hits the TV. Infrared light is the kind of light that heats matter. Some waves of light have wavelengths that are shorter than visible violet light. This is called ultraviolet light. Ultraviolet light from the sun is what causes sunburns. You can get a sunburn from ultraviolet light waves even on cold or cloudy days. Some of my worst sunburns have come while playing in the snow because the snow just reflects back all that sun and all those ultraviolet lights. Okay? All these wavelengths, including visible light, the colors we can see, are examples of light energy, also called electromagnetic energy. Keep in mind that all these wavelengths are light energy. Remember that energy causes change. All of these forms of light are capable of causing changes. Here in this picture of this infrared camera of this person on the cyclist, the red and orange colors represent the heat of the cyclist, while you can barely make out this cycle that he's riding because it's cooler. All right, Invisible energy. Radio waves have the longest wavelengths and the lowest energy. Radio waves can carry signals over long distances, so they are used for communication. If you have a car and you turn it to the AM or FM dial, these are our longer waves, okay? Can't see them, but they definitely make changes so that we can hear the music or hear the talk show through that. Microwaves have wavelengths longer than infrared light. Microwaves are used in kitchen appliances that quickly heat food. So you have a microwave in your house, it uses invisible energy, invisible waves that take longer than infrared light, but not as long as radio waves, and it heats up the food for us to eat. That's a big change that energy is causing. X-rays have wavelengths longer than gamma rays, but shorter than ultraviolet. X-rays can be used to take medical images such as these pictures of leg bones. So here, X-rays are a little bit faster than ultraviolet. Ultraviolet can burn us. X-rays move a little faster, and we can't see this. And then gamma rays have the shortest wavelength. These rays have a lot of energy. They are used in radiation therapy to help kill certain cells that occur in some types of cancer. So gamma rays, the fastest or the highest frequency of any of the waves, can be used for good to eradicate malignant cells that cause cancer. Or they are also used to turn Bruce Banner into the Incredible Hulk, if you've ever read the comics, okay? So all of this is invisible energy, but they make big changes. We can't see it. We can only see the color, but we can hear it through radio waves. We can taste it and touch it when we warm up food in the microwave. We can detect it through cameras to see what's hotter or colder. We can get burned by it. We can have X-rays, which go through our skin and show us our bones, and we have gamma rays, which can fight off some cancerous cells. All of this is powerful stuff that we as humans cannot see. Electromagnetic radiation can be helpful and harmful. Many engineering designs use electromagnetic energy to solve problems. Here are a few more handy devices that work using energy waves. Cell phones and wireless internet routers, or Wi-Fi, which we all have to use for online learning, use radio waves. Bluetooth uses radio waves to connect electronic devices without wires. Two-way radio communications can be very powerful. Radio devices can communicate to and from ships at sea, airplanes in flight, and spacecraft. So with the International Space Station, we're sending radio waves back and forth so that we can communicate. Your phone sends Bluetooth radio waves to your headphones. All of these are invisible things, but they make life easier for us. These are ways in which this electromagnetic or light energy can be helpful, okay? Other ways radio technology can be helpful, or light technology can be helpful, is radio waves are also used in radar technology for tracking objects and forecasting weather. Microwaves are used in the network of satellites and devices that make up the Global Positioning System, or a GPS system. So if you've ever got lost, turn on your phone to try to find it where you're at. It uses microwaves transmitted from all the satellites up in the sky to pinpoint where you are and help you find your way. But though electromagnetic energy can be very useful, some forms of radiation can also be harmful. You already know about sunburn, and too much exposure to X-rays can cause some types of cancer. And certain materials that are called radioactive give off radiation. Some radiation may be in the form of gamma rays. Because of their high energy, gamma rays can be deadly to living things. except Bruce Banner, but he's also a fictional character. This radiation can cause damage to living tissue. Therefore, radioactive materials must be contained and handled very carefully if they are used for technology. So here we have this hazard symbol that tells us something is radioactive. Okay? So thinking about how ultraviolet, infrared lights, how microwaves, gamma rays, and all those other types of rays or waves affect our daily life, how they can make changes, whether good or bad. You are going to answer 5 to 10 questions in today's Google Classroom assignment to show how you understand what we cannot see, this invisible energy. With that being said, thank you for tuning in. I hope you have an awesome day, and I will see you real soon.